welcome to this IChemE Global Awards webinar. My name is Matt Stalker. I'm your host for today's presentation. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely recognised as the world's most prestigious chemical engineering awards. Today we'll be announcing the winner of the IChemE 2020 Team Award, sponsored by Baker Hicks. This award recognises the team that best demonstrates the implementation of a project, process, product or service within the chemical and process sector. And joining us now is Baker Hicks Business Development Director, John Lawton.
Hi everybody, and welcome to everybody, and congratulations to all of those who have been shortlisted for this award. My name is John Lawton, as mentioned, and I'm the Business Development Director for Baker Hicks, and we're proud to be sponsoring this team award in 2020. Baker Hicks is about a 1,000-person company providing professional services across a wide spectrum of the process industries, including pharmaceuticals, biotechnology, chemicals, the nuclear industry, and a whole host of other regulated industries. And as I mentioned, very proud to be sponsoring this award for the second year in a row. And Matt, I'll hand back to yourself to go through the nominations.
Thank you very much, John, and thank you to Baker Hicks. We'll hear from John again later when he reveals the winner. But without further ado, here are our finalists. We have the Centre for Process Innovation, Dow Consumer Solutions, Dow Silicones Belgium, a joint entry from Imperial College London and Sipsmith, Marsh JLT Specialty, a joint entry from Sellafield Limited, the Office for Nuclear Regulation, AWE Aldermaston, Dounreay Site Restoration, the National Nuclear Laboratory, and Orenco Capenhurst. Another joint entry, this one from the University of Leeds, Imperial College London, the National Nuclear Laboratory, the Nuclear Decommissioning Authority, Sellafield Limited, and the Universities of Lancaster, Loughborough, Birmingham, Bristol, Manchester, Sheffield, Strathclyde, Surrey, and UCL. And finally, an entry from the University of Strathclyde. All of our finalists have been invited to join us today to give a short presentation on their work, and subject to time, we'll be inviting you to take part in Q&A at the end of each presentation. You can ask your questions via the questions box in the GoToWebinar portal. We're also live tweeting throughout all of our 2020 IChemE Global Awards webinars. You can get involved using the hashtag IChemE Awards. With that in mind, let's get started with our first finalist, and we have a pre-recorded video from the Centre for Process Innovation.
Is everyone ready for the meeting?
Yes.
I'm ready.
Of course.
Yes.
Yes.
Ready.
Ready.
Of course. Definitely.
Great. We have been shortlisted for the IChemE Diversity and Inclusion Global Award and for the Team Global Award.
Oh, why? What did we do?
We're so diverse.
I'm from Taipo, Hong Kong.
Madagascar.
Jamaica.
Xi'an, China.
Middlesbrough, the nice part.
And inclusive.
I created a mentoring scheme for new starters.
I joined the mentor scheme.
I did a lunch and learn event to teach people about different religion.
I went to the lunch and learn and ate the food.
I helped develop that radio network for people who are hard of hearing, like me.
And I grew a beard.
And we are a team.
You're on mute.
You added a background. That's a filter.
Never mind. Anyway, we have to make a video.
Can we do a pass the pen video?
Guys, remember we also do scale up on new processes and technologies.
Across all process industries.
We help small and large companies.
No, I'm not going to do that.
Can we give some specific examples?
We helped a customer scale up a novel recycling technology.
And it helped them secure millions of pounds of investments.
We're developing a process. COVID-19 vaccine.
We help customers produce new and novel products.
We developed a scalable graphene oxide purification process.
We've helped loads of SMEs with process and technology development.
And large companies as well.
Excellent. Anything else?
How about how supportive our management are?
Great suggestion.
To always support our ideas.
Great suggestion, Min.
Oh, sorry, my computer cut out.
Great suggestion. Oh, great suggestion, Libby.
I think we should definitely talk about safety now.
You're always talking about safety.
Libby, have you done a risk assessment for that activity? Is that tower safe? Is it HSE compliant?
What?
George, let me check. Does that bird length meet the World Health Organization guidelines? Our team does lead the process and chemical safety for the whole business unit.
And because our work is so varied, it covers almost all process industries.
And we're good at sharing knowledge and best practice.
So safety is a key consideration in all of our projects.
I think it helps that management focuses on opening doors for the team. In fact, our team works more like a family than a team.
Maybe we should include our family to show how close we are.
The Windows wall is just saying no.
Do you know, I think we should talk about me being a lower limb amputee and the time I won a silver medal at the Paraclimbing World Championships.
What's that got to do with our team?
Absolutely nothing. I just want to get it onto the video.
I understand.
Exactly.
I totally agree.
Mum, why are you wearing my medals?
I think the key message is that we're a diverse team. We work really well together.
On complex projects across a range of industries.
Thanks, everyone. Now let's do that awkward goodbye that happens at the end of every Teams meeting.
Bye. Bye. Bye.
Bye.
Bye.
Hi guys, great meeting.
Well, how about that then to get started? It's the second time I've seen that one, and I enjoyed it just as much as the first time. Very good. I like that one. John Williams from the CPI is with us. If anyone's got any questions about the entry or the work of the CPI, now is the time to put it into the questions box. And if you've been suitably inspired by that, I'll give you a moment on questions, and you're thinking about submitting your own entry to the IChemE Awards next year, we open for entries typically around the start of March each year. So keep an eye on our website for more details, icheme.org/global awards. I've had one suggestion that we should introduce a new category already for best video. Very good. Somebody's asking where we can see the video again. So, John, where can we see that video again?
Yes, if you want to see the video again, it's on the CPI YouTube channel, or if you Google CPI Process Technology Team, you can see it there as well.
Great, thank you. And another question we've had, are the people all generally located in the UK?
From CPI, yes. Yeah.
Yeah. Okay. Well, look, thank you very much. I think that's all the questions on that one. We're going to move on. Thank you very much. So our next presentation is representing Dow Consumer Solutions. Please welcome Kaylin Frechelle.
I think that.
Can you hear me and see my screen?
Yes, we can. Yes.
Trying to get it to go into presentation mode. There we go. Got a few extra things here. So, hello, my name is Kaylin Frechelle, and I'm honored to be representing our team from Dow Consumer Solutions. Today, I will tell you about our global team consisting of research and development, technical service and development, and manufacturing, how they worked across geographies to develop, implement, and qualify new process technology for customization and packaging of liquid silicone rubber. My computer seems to be rather slow. Oh, there it goes. So I wanted to start by telling you a little bit about what liquid silicone rubber is and how they're used. They are two-part systems which are blended and heat cured for rapid parts production and serve a diverse range of applications, from food contact and infant care to automotive applications such as electrical insulation or automotive safety. You might be familiar with silicone bakeware or silicone watch bands, but there are many things that we use on a regular basis which function better and longer because they use silicone elastomers. A couple of examples, LSR gaskets are used for protecting electrical components in our cars, which helps to extend their reliability and their lifetime. It is LSR's elasticity and strength that enable rollover airbags to maintain pressure. And LSRs maintain their flexibility and durability in harsh environments compared to organics, which is why silicones are trusted to perform in the application sometimes up to decades. This shows an overview of the new finishing technology. Historically, LSRs used batch mixers paired with de-airing and packaging equipment. The team modified the existing packaging equipment to design a semi-continuous process for customizing LSRs, thus eliminating a batch mixing step. Implementation of this technology improves productivity by more than 30%, decreases the standard deviation of many of our quality parameters, while also decreasing the waste generated. Due to the process intensification, the capital costs and footprint are advantaged over batch mixers. And LSRs are used across a wide range of applications, from automotive parts that require phenyl or fluoro compounds that would be concerning to be in contact with infant care or medical application products. So this technology provides the ability to dose and blend additives just before packaging, greatly reducing any concerns about cross-contamination, and also providing higher flexibility in production with a greater ability to serve customers with unique products. This technology has been deployed to 3 geographies with and qualified with various customers. And this required a talented global and multifunctional team, which now I'm going to tell you a little bit more about. Taking into consideration the range of products to be made across the many markets, our process R&D team used design for Six Sigma approaches to define the system requirements. Equipment was selected to achieve fast changeover and robust quality control for a wide range of ingredients. Some of the ingredients that go into formulations range in viscosity from water thin all the way to flowable solids. This group also collaborated with other functions through the implementation and demonstration of the new process technology. The engineering and manufacturing team members partnered with process R&D to tailor the process to the local facilities and the unique product mix. This group led the capital installations and startup. The process automation experts implemented the necessary control schemes to ensure tight quality control through real-time monitoring. And ultimately, this group owns the process operations and is responsible and has driven continuous improvement in the process technology. Our technical service and development team are the experts in applying our product technology at our customers. They helped define statistics-driven qualification plans in order to ensure that the products perform in the end applications. They were ultimately responsible for and intimately involved in product-specific testing and also led the qualification efforts with our customers to implement this new process technology. Their intimate understanding of customer needs and requirements were essential to be able to successfully deploy this new process. The scope of the project required coordinated efforts across the 3 functions that I mentioned. Process R&D led the project from concept generation through the internal validation, ensuring that the design, installation, and startup of the new process went smoothly. At the point where customer and product-specific requirements became vital, project leadership was transitioned to technical service and development. And this allowed us to leverage the application-specific knowledge and customer relationships. In a design, process design project, it can be easy to push a project through from design to implementation and ultimate qualification. It was very remarkable with this team, the collaboration, and that collaboration fostered improvements in the technology. Members from the initial design team were instrumental in gaining buy-in for the technology and also providing guidance on how to implement it in the other geographies and with different products. But they also allowed for new ideas and adaptations. Because the team members embraced change, the technology was able to advance. Also, solutions identified in one geography were able to be shared and optimized in other regions. Global implementation of this technology has allowed us to better serve our customers. In a capacity-constrained environment, this technology allowed growth in LSRs and also made Dow a more reliable partner for innovation with our customers. The ability to introduce additives at the point of packaging has expanded the opportunity to fully serve our customers' needs with customized products. The team collaborated to adapt the process to various manufacturing environments, control systems and for the manufacture of a diverse range of products, and ultimately successfully deployed this new process technology for customization and packaging of LSRs. With that, I thank you for your attention, and I'm happy to take any questions.
Okay, thank you very much. So we will pause for just a moment to give you a chance to type those questions in. If you have one, please type it into the questions box on the GoToWebinar portal. And while I give you a moment on that, now is a good time to thank our volunteer judging panel led by our head judge, Keith Batchelor. The judges work tirelessly to review and score every entry across all of our categories, and you can find out more about their work on the IChemE Global Awards web pages. We have a question. At which sites were the pilot and manufacturing runs carried out?
There's a site in North America, Europe, and China, and each site carried out sort of pilot testing as well as implementation into manufacturing.
Okay, thank you very much. That's all we have in terms of questions, so we're going to move on. Thank you very much. It's now time for our third finalist, and this is Dow Silicones Belgium. Please welcome Francois de Boyle.
All right, so I need to share, I believe, the proper screen. Which screen do you see? I don't know.
We don't see anything at the moment.
How do I share now?
Now we do, yeah.
Screen here. I have the two screen monitor 2. There we go.
Yes, now we can see your PowerPoint.
All right. Oops, sorry. Let me do this. Let me move this window out. How do you see this? Okay, sorry. So, hi, welcome. Good afternoon, everyone. I don't know why. Okay, so do you see the proper screen? Sorry.
Yes, we can.
All right.
Yes.
All right. Okay. So yeah, I'm actually part. Yes, belongs to Dow Silicone Belgium. Actually, also part of Dow Consumer Solution. Like Kaylin just introduced, this part of the Dow business segments. So today it's a great pleasure for me to present the work of a great team. And let me move. Yeah. Whoops. Sorry. One slide. Yeah, right. Okay, so as you can see, it's also a quite global team here of people who worked in the development and commercialization of a family of liquid silicone rubber, but maybe a shorter family, which is optical silicone rubber, used in a wide variety of LED lighting fixtures, designs and applications since now 2012. As you can see on this map of the worldwide map, our team is enriched by an extreme diversity of scientists and engineers issued from actually various generations, as you can probably see on the pictures here of colleagues. Some of them are actually retired today, 3 of them here on the screen. And colleagues coming from various origins and with a quite diverse material science expertise and background. And this is actually, as you may notice already, the overall strength of the new Dow. I mean, as it integrates silicone business in addition to prior thermoplastics and polyurethane business of the former Dow before 2016. So today it's a short version of this story that made this team of people you see here successful, and that I would like to share with you. The first things I would like to share with you is the story around LED lighting. And well, one key thing to recognize is that since the invention of the incandescent bulb by Edison, end of the 19th century, you need to know that the modern LED invented by Nakamura have really revolutionized the science of illumination since 2000s, basically the early 2000s. So I would like today to enlighten your attention on these proven benefits that our family of optical silicone have brought to the wide series of LED lighting application and beyond, as illustrated by the few examples of success with customer and lighting industry partners shown on the right-hand side of this slide. So you can see from top to bottom an example of UVC water purification module designed and commercialized by Philips, an outdoor street lighting fixture or module within a street lighting fixture developed by VS Lighting, the famous adaptive driving beam headlamps based on LED matrix systems designed by Hella for Daimler back in 2015, and the fourth example here from Gajon with a unique design of collimator used in retail lighting. So really the diversity of use and spread of LED lighting technology today is essentially has been driven since 2000s by the access to high power LEDs and the need of high efficiency in light extraction and control, the opportunity to reduce maintenance and ensure long-lasting performance of lighting fixtures and module, the opportunity to combine multiple features at the secondary optic level, and the necessity to reduce our carbon footprint and energy consumption with the adoption actually of LED as made possible. You need to keep in mind that the savings using LED instead of traditional incandescent bulb technology for lighting is saving up to 70% of energy, electricity in daytime and 50% in nighttime uses. So now let's see well, what optics component made of silicone instead of traditional thermoplastics such as glass and thermoplastic slurry can effectively bring to this LED application, the optical designers and engineers. So, well established. I mean, the Silastic brand established at the time of Dow Corning in the past. I mean, for liquid silicone rubber, these moldable optical silicone offer readily optically clear and or white reflecting, and at the same time tough material after injection molding and then curing in a mold cavity, with excellent environmental stability, optical performance, and design flexibility as the key attributes. And you can see on this few pictures, illustration, example of a total internal reflectance lens with highly polished mirror-like surfaces, a light guide with the toughness and flexibility characteristic of silicone rubber, a linear optic design with surface microstructures on the outer surface for controlling light scattering, for instance, an holographic type of effects obtained by really submicron sort of grooves acting as a diffraction grating and splitting the light into the series of rainbow spikes surrounding a center white light beam, which can be nice in certain illumination scenarios. And last but not least, we have a highly white reflecting up to 99% curved shaped silicone reflector with negative draft angle, which enable to control the beam angle more effectively than with a specular reflector. Now, coming back a bit on the detail of one, let's say, true example of now industry project, and I would call this team of teams, partnerships with industry partners, is given here. As you can see, Engel, ACH Effner, Hella for Daimler have really collaborated to bring this matrix LED adaptive driving beam to reality. And you need to realize that 52% of driver fatality, and up to 71% of pedestrian deaths happen overnight on roads. So improving the, let's say, use of high beam on a permanent basis and having a dynamic high beam lighting pattern on the roads, I mean, effectively is readily a safety attribute to the modern LED lighting fixtures. So this is, I think it's a successful example of teamwork with industry partners, which started in 2015 and have continued to grow actually, as I mean, up to 35 car models today are equipped with these matrix ADB headlamps. Next slide, moving. Yeah. Now, moving further, I mean, beyond, I would say, automotive lighting, we have optics design made of this silicone optics material, widely implemented in retail, in stadium, in architectural, street lighting application, as you can illustrate from, from the picture of the previous slide, sorry. So you see all these professional lighting elements has really been possible. At least some of them are unique to silicone because of the outstanding resistance, again, very high lumen fluxes and heat generated by high power LED and chips on board light sources. The intrinsic resistance of silicone material against UV without the need of any UV stabilizers. The benefits to bring highest ingress and impact protection. So these are important. You see, when you read IP or IK rating on a lamp fixtures, you can eventually buy in the Brico. This means rating of ingress and impact protection. So this is important for any lighting fixtures, particularly outdoor. And the natural, I would say, best flame retardancy performance of silicone against thermoplastics. So many of case studies and detailed example can be found in outdoor.com website if anyone is interested here. And I would like actually now to come back to the team aspect of this, let's say, project. You can really see on the picture here the Dow team spirit and dynamic. Now there is almost 9 full years I'm personally working in this segment as a technical service and development support to customer, and working with colleagues spread worldwide. We all aim and enjoy to bring the science of silicone, the chemistry of the material, the physics of optics in this particular case, and the engineering of liquid injection molding to customer, leading innovation in LED lighting. So I believe the smiles on our faces, they are real, I can tell you, when we participate to conference, trade shows, motivated by the challenges and passionate about the opportunities we all pursue. And finally, we are, I believe, I'm representing today this team of people, and I'm proud to be, with you. And time to time, it's nice to be rewarded, such as being selected as finalists for an IChemE Global Awards today. So with that, I'm gratefully thanks for your attention.
Okay, thank you very much. So once again, we'll pause for questions. And if you have a question, please type it into the questions box now. And while we have a moment on that, don't forget the winner of this award automatically qualifies as a finalist for our top prize, the Outstanding Achievement in Chemical and Process Engineering Award. We'll be announcing the winner of that prize tomorrow afternoon. Why not join us for that webinar too? You can register at icheme.org/global awards. Okay, we don't appear to have any questions, so we're going to move on. Thank you very much. Next up, we have a video representing the joint entry from Imperial College London and Sipsmith.
Apologies, Matt. I'm just having a bit of trouble with this video. Let me just try it again. I don't know whether you guys are seeing that error message that I'm seeing.
No, I'm not. If not, we'll perhaps circle back and move on.
Okay, let me just try one more time. No, it seems to be a formatting issue. It doesn't seem to want to play, unfortunately. Ever sorry about that.
Okay, well, look, let's move on. We'll figure out a solution in the meantime, but if we can move on to our next finalist. This is Marsh JLT Specialty. Please welcome Nick Holland, Zaid Lafta, and Abdullah Mohammed.
Thank you very much. And we've got the presentation up. Excellent.
Hi, how are we doing?
Okay, thank you. Yeah, very good. Okay, we'll get started. So hello, everyone. I'm so glad you can join us today. And we're most grateful to the Institute of Chemical Engineers for including us as first-time finalists in this year's Global Awards. So by way of introduction, my name is Abdullah Mohammed. I'm a chartered mechanical engineer. Today I'm joined by my chemical engineering colleagues, Zaid Lafta and Nick Holland, with the intent to share with you our consultancy story and to answer any questions you may have. So let us start with an exciting introduction of our risk engineering team. So Marsh has been providing risk management and engineering services to the energy and power industries for over 40 years. We have collaborative engineers positioned in hubs all over the world. And today our presentation features experiences and case studies from our Middle East and Africa risk engineering team. So within Middle East and Africa, our team has grown from 1 to 19 professional engineers within the last 15 years, with 2 recent new joiners. We're located in the UAE, Saudi Arabia, India, and Bahrain. Between us, we represent 10 different home nations, and each of us brings diverse professional industry expertise to our clients. We're very active in our region, and over the last year, our team members have surveyed over 200 process plants for operational risk quality and production planning optimization. We work with a broad range of operators, including national and international companies, as well as independent single-site operators who may sometimes miss out on the benefit from the wider governance of a major corporate presence. A feature of our service that I personally have found professionally stimulating since I joined Marsh is the challenge of working with such an enormous range of process technologies, many of which are operating at a truly world-class scale. Through participating in this event, we found this to be a great opportunity to reflect on our recent achievements as well as our industry impact. I'm pleased to say that we're very proud to be the trusted risk advisors for replacement capital and free cash flow risk exposures in excess of over $200 billion per year. Our advice includes how energy and power operators may transfer their individual risks, sometimes as high as $8 billion per single credible loss event, over to insurance products. Our team philosophy features 3 key attributes. Number 1, we blend chemical, mechanical, electrical, and construction engineers to provide a complementary team service. Our team of experts all work together to create bespoke objectives and improvement plans for all of our clients. Number 2, a key goal for our team is improving the operational resilience of clients within the region and preventing process loss incidents from occurring, a topic that Zaid will explore next. And number 3, we continually transform our services with innovative solutions in response to the changing industry expectations highlighted by our global benchmarking and analysis of major losses. And we look forward to Nick sharing some cases after Zaid. So next up, it gives me great pleasure to hand you over to Zaid Lafta to present our core activities and recent accomplishments.
Thank you, Abdullah. So this year, with the effects of the pandemic and a lower oil price, process safety has become even more important in our industry. So it's critical that we provide a truly great experience for our customers. Our core service is to provide operational and construction risk engineering consultancy for both the clients in terms of reducing their risk profile and for insurers where the risk is ultimately transferred. To do this, we need to quantify the risk And we do this through site visits to ascertain the implementation of hardware, management systems, and emergency response tactics. And then we support this through our modeling capabilities. You'll see an output of our modeling capabilities on the next slide. We really are proud of the diversity of our team, as Abdullah gave some headlines to, in terms of the engineering disciplines, the background, industry experience, but also in terms of the cultural background and the languages spoken. We have close to 50 engineers across 14 locations globally. Throughout, we work in collaboration with our clients, delivering loss prevention seminars, workshops, process safety culture assessments, to name but a few. Our position papers have been of particular significant value to our clients in explaining the latest in industry standards, and where we make risk improvement recommendations, these then help to bridge the gap by detailing the expected actions in what is a best-in-class work process or hardware features. All our position papers and publications produced by the Marsh Global Energy Risk Engineering team is made freely available on the Marsh website. The 100 largest losses is particularly popular, and it's even made mandatory reading at a number of our client sites. And again, you'll see an example graphic from the 100 largest losses on the next slide. We're fortunate to be in a position where we work with a number of clients across the world, and that allows us to compile and compare site performances through our analytics and benchmarking, which puts us in a unique position to help influence industry standards. And finally, we're very proud of our COVID-19 pandemic response. We led the industry in implementing a business continuity plan to ensure we continue to serve our clients' needs, and it was a model that was then widely adopted by our peers. This initially started by setting the industry standard on virtual surveys, but now is expanded to adopt and implement augmented reality headsets to allow us to remotely tour the sites. And with that said, I'll hand it over to my colleague, Nick.
Excellent, thanks, Zaid. So we believe that the breadth, depth, and quality of our team's service are unsurpassed in the insurance industry. And recently, we've broadened our traditional risk engineering approach, driven by the wealth of our international talent, to become much more consultancy focused for our clients. We lead our industry in research and development in areas such as business interruption reviews, asset integrity, operational excellence, construction risk engineering, terrorism studies, as well as third-party liability assessment. A notable example in this area is we maintain process models that include over 150 million tons global integrated oil, gas, and petrochemical production. And our leading process reoptimization and supply interdependency experts looking to drive gross margin improvements across all of these in post-loss planning event scenarios. Our diverse engineering team has the ability to offer an impartial third-party view of what good looks like. And we support the corporate stewardship of risk engineering activities by hosting forums with executive leadership teams. At these events, we justify our improvement items using tools such as key performance indicators, enhanced analytics, process safety culture assessments, as well as our recognized benchmarking. This is a platform to enable risk managers to influence their key stakeholders in their business, as well as their sponsors, and it drives long-term benefits for loss prevention, and helps facilitate corporate governance as well, reinforced by our industry-recognized benchmarking. Our benchmarking analysis allows comparison against peers in a global population, where if required, we can do more targeted peer groups as well. The dynamic database includes values from over 1,300 surveys and dates back over 16 years. We cover 200 clients in our region and over 750 independent assets being operated. A client's loss prevention performance is described in terms of a classic quartile type reporting, giving clear perspective on where change may be possible and where it may be needed as well. As part of our analysis, we include recommendations and actions, and where appropriate, we'll show some analysis as well on how those improvements might affect the overall performance with time. This is useful data for risk managers as well as insurers as part of the insurance placement and premium evaluation process. It's fair to say the onshore oil, gas, and petrochemical industry has seen a high number of losses recently attributed to asset integrity failures as well as inadequate operator discipline. In response to this, we've deployed our team's technical expertise across a range of targeted deep dive services. These are a suite of in-depth surveys conducted by specially qualified and certified engineers, designed to provide a better understanding of risk quality improvement recommendations and deliver enhanced risk improvement value. We've had great success with these and identifying and mitigating high severity process risks in the last year. We are proud to help our clients organize complex insurance placements that provide for them balance sheet protection. And this enables companies to invest in themselves, benefiting wider society in terms of economic growth, job security, and prosperity. Now, a key goal for our team is improving the risk quality of operators in the region compared, say, versus their global peers. And we've got a great case study. We've been able to help a regionally headquartered global petchem company achieve top quartile performance through the identification closure of some 2,000 recommendations over the client relationship lifespan. And with that, I'd like to thank you for all your attention. It's wonderful to be part of this IChemE industry recognition event. We've thoroughly enjoyed listening to the other nominees so far and experiencing a wealth of professional diversity, which is incredible and truly inspiring. So thank you very much. We welcome your questions.
Okay, thank you very much. We have our first question. What are the main changes in attitudes from operators to risk management since the effects of COVID have been felt?
So it's fair to say, from a risk management perspective, we've had kind of two halves to 2020. We had the kind of the knee-jerk reaction in the first half, and that's provided kind of a few challenges, very much so in the second half when we look at people management. Very early on, some of the items that we're managing, or some of the advice that we're trying to recognize, was around what's going to happen from a cash flow perspective. So we've got a number of companies could be looking at like free cash flow in the business, and what's the rash decisions they're going to make on the back of that, and how is that going to affect risk quality. And as risk advisors, and especially working on behalf of insurers, the kind of things that we're worried about are, well, what are we deferring? What are we not doing? What inspection plans do we have best laid out, which we're going to be pushing back? What repair or remediation plans do we have put in place for planned maintenance on equipment that we're pushing back? So there's a lot of attention, a lot of focus very early on in the COVID situation with what's the impact going to be, what's not going to get done with the resource constraints, with cash flow constraints. And what's been quite interesting, actually, what we've seen on the back of all this is very early on, people were really worried about people and getting people into these operating facilities and running facilities. But we've actually seen that the people management side of things has been very good. Where some of the challenges are coming in now is people have been so attentive and reliable at coming in the first half of the year. They're now struggling now to find time off. They've got so much time off that they haven't taken this year that operators are starting to struggle with balancing out the manpower towards year end, ensuring people get some appropriate time off. So initially people were quite worried about people. And that's actually coming in the second half of the year. I don't know if my colleagues want to join in on that. Kind of Zaid, what do you think?
Yeah, absolutely, Nick. So we drafted and published a position paper on inspection deferrals and the best practices with those midway through the COVID pandemic in response to a lot of the drivers we were seeing in terms of deferrals. But just to echo Nick's point in terms of the second half of the COVID response, we definitely saw a can-do attitude and embracing the new norm as it came to be. So, our inspiration for the augmented reality headsets is from what we were seeing deployed at a number of petrochemical facilities where vendors couldn't be deployed to site to assist with the turnarounds. They would ship the augmented reality headset so that they could guide and advise the machinery techs and the mechanical techs in terms of the repair plans. So what has historically been a very archaic industry has really embraced some pioneering technology to meet the need.
Thank you. And a follow-on question to that has come in. How has the COVID-19 affected the way that the team interacts with each other?
So as a kind of service that we provided, we are used to spending a lot of time on the road. So we're all kind of used to remote working in a certain way because we'll be aiming to spend maybe a third of our years on the road surveying plants. Where we've definitely had to adapt is, from a survey perspective, we're not going onto the site, so we're all working from home. And we've had to change the way that we operate our surveys and how we service our clients, the information that we collect. As a team, we've probably had some more interactions actually. So being in this virtual space is much easier. We're all finding it a lot more flexible to get in touch with each other virtually. I used to find, if you've got people that are out on survey, it can be quite hard to get hold of people, right? So you're traveling, you've got time to travel, you're on site, maybe you're looking after colleagues who are joining them. We're we have guests. They're on the survey as well, so it takes up quite a bit of time servicing those guests. So as part of it, what I found from a team perspective is some of the virtual tools are actually great at checking in and getting people together. And we've had to kind of get used to virtual meetings, getting set up with MS Teams, getting set up with Zoom. And our response in terms of other tools as well, probably been a little slower. So we're starting to experiment now with some other tools to help us collaborate with the work packages that we're using. But there has been a certain element of business as usual, I guess, because we are used to kind of working remotely from each other. But we've got some plans ahead to improve the way that we work on documents together.
Okay, thank you very much. We need to move on, so thank you for your presentation. Next up, we have a video on behalf of the joint entry from Sellafield Limited, ONR, AWE Aldermaston, Dounreay Site Restoration, the National Nuclear Laboratory, and Urenco Capenhurst.
Well, hello everyone. My name is Sean Jarman. I am an inspector with the Office for Nuclear Regulation, where one of my roles is to act as the course manager for ONR N20, the Nuclear Chemical Process course. If I may begin with a little background, the Office for Nuclear Regulation are the statutory regulator for the nuclear industry in Great Britain. Our regulatory bodies include nuclear safety, health and safety on nuclear sites, civil nuclear security, transport of nuclear materials, and nuclear safeguards. We primarily regulate in accordance with the requirements of the Energy Act 2013 and the Health and Safety at Work Act 1974, together with their associated relevant statutory provisions. Well, what is the ONR N20 course? N20 is the Nuclear Chemical Process course. It has existed for quite some time in ONR, and over the last few years I've acted as the course manager, and I like to think it's currently in better shape than it has ever been. It is designed to provide regulatory staff with a grounding in the effective regulation of sites with chemical plant through giving them an understanding of how that plant has evolved, its history, how it is operated, and the challenges that it represents. The course is unique in ONR in that almost all of the content is actually presented by the relevant duty holders themselves. The sharing of the knowledge and understanding of the plant and its operation from those that know it best. The ONR N20 course was designed to promote understanding of the history, engineering, and hazards associated with chemical process plant across the GB nuclear industry, much of which was designed in the 1950s and 1960s, and while post-operation clean-out and decommissioning are now priorities as part of the risk reduction strategy, these were not objectives when the plant was designed, representing unique challenges. We're absolutely delighted to have been shortlisted as a finalist in the IChemE Global Awards, and welcome the recognition of this course as a really solid example of mutual cooperation between regulator and regulated in the interests of safety in what is genuinely a challenging and fast evolving area.
Okay then, Sean Jarman and Keith Johnson have joined us on the line, so if there are any questions about that presentation or the work, we can take them. So we'll give you a moment to type the questions in. Okay, we don't appear to have any questions, so we're going to move on to our next presentation. And representing the joint entry from the University of Leeds, Imperial College London, NNL, the Nuclear Decommissioning Authority, Sellafield Limited, and the Universities of Lancaster, Loughborough, Birmingham, Bristol, Manchester, Sheffield, Strathclyde, Surrey, and UCL, it's Michael Fairweather.
Sorry, I'm not getting anything about sharing a screen.
Okay, Gareth, can you help there, please?
Okay, can people see that?
Yeah, we can see that and we can see you.
Okay, thank you for the introduction. My pleasure to be here representing the Distinctive Consortium. Distinctive is an acronym for Decommissioning, Immobilisation and Storage Solutions for Nuclear Waste Inventories. I was PI of this project, and really in this short presentation I just want to give you an overview of the project itself and say a few words about the team contribution. So first of all, thanks to the Engineering and Physical Sciences Research Council, who funded the project as part of the Research Council's UK Energy Programme. And also, I'd like to acknowledge funding from our key project partners, the National Nuclear Laboratory, the Nuclear Decommissioning Authority, and Sellafield Limited. So by way of background, the project started in 2014, initially running for 4 years, but we were granted an extension through into 2019, basically because of difficulty in accessing some facilities, in particular active facilities. Overall, the EPSRC donated about £5 million, and taken together with university contributions and £2 million from industry, that gave us a total funding of about 8.2 million, which is fairly large for a research project supported by EPSRC. We had a world-class university network, 11 universities, the logos are there, I won't read them out, but all of the universities have track record in undertaking nuclear-related research, and of course the 3 project partners that I just mentioned. What were the aims and objectives? Well, we're saying a few words about the background, really. The main issue is UK government recognises decommissioning of legacy nuclear facilities as a national priority. And the strategy there is to reduce decommissioning costs by 20% over the lifetime of decommissioning, and also to have a joined up approach to R&D across all people involved in it. And the main enablers of that are innovative R&D to bring in new methods for waste management and decommissioning, and skills development. Additionally, any of this work or all of this work should be of benefit to the economy, and it should be of benefit to UK industry, helping to establish them as global leaders in the field. But of course, in terms of gaining public acceptance of that strategy, then we need to demonstrate our ability to safely manage and dispose of the waste. So because of those factors, the strategic aims of the consortium were, first of all, because this is an EPSRC, largely EPSRC project, to carry out internationally leading research, but we wanted to support research that provided routes for innovative technology developments that could be rolled out on plant and affect approaches to managing waste. We wanted to foster and develop new multidisciplinary research partnerships, and given the demographic within the industry, train the next generation of researchers with appropriate skills and experiences. We also wanted to provide a focal point for government, industry and academics to discuss the issues, and of course provide a route for public understanding of the needs for the R&D and opportunities and solutions. Clearly, I don't have time to go through everything we did, but this is just the schematic of the sort of areas we were involved in. So on a reactor site or a radioactive plant, we've got waste. It may be stored in ponds, silos, and we undertook work to looking at the processing of the waste in treatment facilities, into moving on to the form of the waste, the way the waste is packaged into interim safe storage. We also looked at long-term geological disposal facilities, as well as structural integrity of all the associated infrastructure and environmental issues, related environmental issues as well. There were 4 technical themes: AGL, Magnox and exotic spent fuels, plutonium oxide and fuel residues, legacy ponds and silo waste, and structural integrity. And the core team undertook 48 individual projects made up of 10 research fellows and 38 PhD researchers. So the team collaboration really comes about because nuclear decommissioning and waste management mean that teamwork and interdisciplinarity and collaboration are essential. And how did we bring that about? Well, the overall program and the individual project scopes were developed collaboratively between all partners, both before the proposal was submitted, but also evolved after we'd been awarded the grant. Each project had academic and industry supervisors and additional industry contacts, and that engagement continued throughout the program. So we held annual meetings and theme meetings, again, theme meetings at 12 monthly intervals between the annual meetings, which typically attracted 100 to 120 attendees, 50% of which were always from industry. We held regular management meetings, industry roadshows to broaden engagement, challenge-led meetings, which were ad hoc meetings addressing specific industry challenges. And we had input from an international advisory group, which had 28 members over and above the organisations I've already mentioned, many of whom from the US. The way we operated really enabled the researchers and academics to understand industry needs and context, but equally it developed a good understanding of the research outputs in industry and enabled partners in industry to champion that work internally. We also broadened that engagement through interactions with regulators and policymakers, with researchers being involved with government working groups and government reviews. So a couple of examples were involved in the all-party parliamentary group on nuclear energy, and one of our researchers was a special advisor to the House of Lords Science and Technology Committee investigating nuclear R&D. We also engaged with society and stakeholder groups via public talks. We attended UK and international festivals, participated in social networks. We developed an online stakeholder engagement exercise and had a website and frequently appeared on social media. And certainly researchers commented to the media in all its forms on a number of occasions. So the funding allowed us to develop new technologies, processes and knowledge that underpinned waste form stability. It allowed us to roll out novel techniques and products on site, and it allowed us to develop understanding that was embodied in operational procedures. So the 6 green bullet points there are just some examples of the sort of work that we delivered. So we delivered some acoustic probes for remote monitoring of waste. That system's installed at Sellafield now. It's about to be commissioned. That's estimated to save over £50 million over the next 10 years. We also looked at work that helped accelerating uranium-containing waste recovery through changes to recovery strategy and packaging simplifications. That's estimated to save more than £100 million over the coming years, and the results of the research helped obtain regulatory consent for changes to the recovery strategy. We did work on hydrogen gas networks in waste sludges to allow better optimization of fills into storage boxes, again estimated to save many millions of pounds, and the outcomes there were incorporated into a technical baseline for transfer and storage of waste. We improved understanding of the evolution of head gas above plutonium oxide in storage cans. And again, that's been of help in respect of improved handling, storage and transportation of those packages. And the work also supported a number of nuclear material safety cases. We also delivered novel ion exchange materials for waste treatment, and also new glass ceramic formulations and processing options for immobilizing the huge plutonium stockpile that we have, should it be decided that we go down the disposition route. So overall, we feel we've influenced nuclear energy policy through expert advice and evidence to the government, as I've mentioned. We generated a cohort of skilled researchers who should become the next generation of experts, with 50% of the researchers moving into the nuclear supply chain. We facilitated new R&D networks. Overall, the activities I've mentioned, 43 industries were involved. So certainly the network was broadened significantly. And overall, all the impacts should ultimately save the taxpayer money by making decommissioning and waste management faster, cheaper and safer. I'll leave you with a few pictures of the team. Thank you for your attention, and I'm happy to take any questions. Thank you.
Okay, thank you very much. So once again, we'll pause. If you do have a question, please type it into the questions box now. Okay, we don't appear to have any questions, so thank you very much, Mike.
Okay, thank you.
Next presentation. Next up, representing the University of Strathclyde, please welcome Sylvia Battock and Mark Hoare.
So now we've got the slides coming up. So I should, can you hear me?
Yes, we can hear you and we can see the slides.
Excellent. Excellent.
Excellent.
I should just explain that Sylvia is controlling the slides, I think.
Correct.
So, so we might have to do a bit of that sort of next slide, please, type stuff, which has become very common these days. So I'm going to feel a bit like Chris Whitty or someone. But I'll start off. So I'm Mark Hoare. I'm a lecturer at University of Strathclyde, and later on we'll also hear from Sylvia. Oh, there she is. And we're going to talk to you about our team, which is called Really Small Science, and about what we do and how it fits into chemical engineering. So Sylvia, can you move on to the kind of, yeah, so, well, there we are. We're Really Small Science. Sylvia's going to tell us about a specific thing that we do, which is called Young Chemical Ambassador, a bit later on, but I'll start by telling you what is Really Small Science and what's it got to do with teams. So next slide, please. Okay, so we're an outreach group. So what do? We're based in a chemical engineering department in Strathclyde, but we go out to all kinds of events, schools, festivals, all kinds of sort of situations and places outside of university, trying to tell people about chemical engineering. What is it? Why is it important? And particularly what we do when it comes to chemical engineering at Strathclyde, but also how that fits into people's everyday lives. And we're trying particularly to focus around kind of social issues around things. So we go out to areas of, say, multiple deprivation. We're trying to raise aspirations amongst children and families to think more about engineering, science, chemical engineering careers, that it's not just something for some boffins who are in some distant place somewhere, but it's for everybody. We're trying to do it long term. We're really trying to be sustainable. I'll say a bit more about that in a moment. And we're trying to do it through really engaging people, so hands-on activities, not just standing in front of people talking at them, but really hands-on. And at the same time, our team, the people who are actually delivering all these activities, who are researchers, PhD students, undergraduate students, staff in University of Strathclyde, they're also gaining something out of this, I hope, as well as having some fun. which is skills around engagement, about how do you talk to people who really don't know anything about science or chemical engineering quite often. How do you talk to them about it in ways that really get them excited? Thanks, Sylvia. Next slide. So a little bit of a history here. We started back in 2013, and actually we started when I got some money from the Royal Academy of Engineering to do a one-off event, but I knew straight away that it wasn't enough for me to just go and do this. I needed a team, and that was always my kind of goal, was to build a team to do outreach. There's some really good outreach work that's been done over the years, but too often, my impression was too often one or two enthusiasts would do it, and then when they ran out of time or they moved on, it would stop. So I wanted to do something that was sustainable, and the way to do that is to build a team. So we started off in 2013 with a team of 5 or 6 researchers. We did a one-off event, and then we said, no, this was really good. It went really well. We want to keep it going. We found ways to keep it going. We found some more funding as we went along. We worked with a lot of different people. We built the team. We got bigger and bigger, and I'll talk a little later about just how big we did get. What sort of things have we done? So we actually try and cover all ages. So a lot of outreach is obviously around schools, but we're really trying to do all ages of kids in schools, right down to early years, nurseries, but also families at community events and festivals and so on. So we're trying to say that chemical engineering is for everyone, not just some narrow section of the population. Next slide, please, Sylvia. So what do we actually do? Well, here's some examples, and I'm not going to go through all the details here, but these are some of the things that we actually do as hands-on activities for our audiences. And this is focused around some of the research that goes on at Strathclyde, which of course is not just pure Strathclyde research, it's also a lot of the stuff that research teams at Strathclyde work with, people in industry, people at other universities. So I think the theme that comes out of this is how teams overlap. Our team of outreach people then work with bigger and bigger research teams, and we also present to teams of people, teams of children, teams of teachers, parents, and so on in schools. So these teams really overlap. So that some of the activities, looking at things like absorption, things like material manufacturer. We're starting to look a lot more at sustainability as well. So one of our future activities that we're designing at the moment is around things like bioplastics and sustainable materials for packaging and so on. So a big range of things to show the people we engage with just how widespread and important in their everyday lives chemical engineering is. Next slide, please. So here's the team in terms of the people doing the engagement. I'm at the top there because I started it, but to be totally honest, now I just sit back and don't do anything and just take all the credit in pure management style. But Sylvia is very much the person who runs the thing day to day and makes sure everything works. And what's the team? Who's in the team? Who actually goes out and does this engagement? You can see lots of pictures of lots of different people because the team is 50 to 100 people at least over the years. Undergraduate students, postgraduate students, staff. And by staff, I don't just mean the lecturers, I mean also the admin staff in our department, all kinds of people getting involved. And that's been really important to us to essentially play a role in the sort of social and cultural structure of the department and the university, not just a thing that's kind of limited to the people actually doing the sort of hands-on engineering and science. Next slide, please. This is just evidence that we are quite a successful team. This was a team award we won last year at Strathclyde at the university. And there's, again, another picture of people who are different to the people in the other pictures because it just demonstrates how widespread our team is and how many different people have been involved. And that award was really all about how our team is not just about chemical engineering, it's about people, it's about being innovative, it's about going out there and telling people how important what we're doing is and what chemical engineering, chemical engineers everywhere are doing, how important that is. Next slide, please. So here's just a little bit on just kind of just how big we've become since that first team of 5 or 6 people in 2013. We've now engaged with getting on for 30,000 people across the UK and internationally. the whole program has grown year on year. We're focused a lot nowadays on, as I say, these areas of multiple deprivation, because we really want to address this whole issue around diversity in science and engineering. I think that's become something that, to be honest, I wasn't really thinking about when we started things off, but it's very much a core of what we're doing now. And we've also started to spread internationally. So we've had people in our team go out to different places. We've even, because we had a connection with a professor who moved over to the US, he's carrying on doing outreach work. So we're trying to spawn off other teams all over the world as well. So teamwork is really right at the core. And actually, this is going to sound a bit cheesy, but that 27,000 people that we've engaged with, I like to think every single one of those is also now a part of the team. So we have quite a big. Okay, I'm going to stop there, and Sylvia's going to go on and tell you more specifically about one of the activities that we've been doing for a few years.
Thank you again for having us speak today. So I'm going to speak a little bit about one of the other parts of our outreach group, which is the Young Chemical Ambassador Program. As Mark explained, the Really Small Science Program is basically an outreach group where we take hands-on activities to schools and the general public, usually as kind of one-off events, but can be continued over a longer period of time. The Young Chemical Ambassador Program is more of a long-term project where we work with a small group of pupils, and we work with them for up to 4 to 6 months on a project rather than just a one-off visit to a school. And this project promotes future opportunities and mentoring for pupils in disadvantaged areas. The project has been supported by the Royal Academy of Engineering, their Ingenious Fund, and the Royal Society of Chemistry. So since 2016, we have worked directly with over 130 pupils, and these are aged 13, 14-year-old pupils from areas in Glasgow that we've identified as being areas of multiple deprivation. And when we are recruiting students for this, we do ask the teachers to nominate pupils that would really benefit from a boost of confidence and from taking part in a mentoring program that would benefit their learning and teach them a bit more about university life and about engineering and science in general. These pupils eventually become young chemical ambassadors with the intention that they will then deliver their knowledge to their own classmates and to their schools in general. And again, with the team aspect of this is that we train our PhD students to be mentors for these high school students. So over the past 4 years that this program has taken place, we have trained 28 chemical engineer PhD students as mentors. So as part of this, they have communication skills, science communication skills, and lots of other really useful engagement tools that will help them in their careers and beyond. So just to tell you a little bit more about this program and how it works, we recruit teams of pupils from local Glasgow secondary schools to become ambassadors for chemical engineering. We've actually expanded this slightly in that we've also worked with schools from Edinburgh City Council and Falkirk City Council. So the recruitment is focused on areas of multiple deprivation, and we really want to pick students who would appreciate the program the most. So the pupils are paired with a PhD mentor who is a researcher, and we train these researchers in science communication and in engagement. And we work with our mentors to design a project around their own research. So it's not just them teaching about general chemical engineering, it's directly related to their own research projects and to their own interests within their PhDs. So the high school pupils will come to a 3-day masterclass at the university. And during this time, they'll get to experience hands-on chemical engineering activities. They'll be given careers advice, a presentation skills workshop, and also a tour of the campus and the labs. This is all to give these pupils an idea of what university is like, and also to give them an idea of chemical engineering, which is going to be completely different to how they may have learned in the classroom at high school. So over the past few years, we try to evaluate this project and see how best it's working. And one way that we do this is through confidence rating. So we ask our pupils to rate their own confidence in giving presentations at the beginning of the program and then at the end. And every year we have seen an increase in the pupils' self-reported confidence, showing that this is something that's helping them to build confidence in their own public speaking, in their science, and in their knowledge. They also develop a presentation and demonstration which is based upon their research projects, and they deliver these presentations to their class, and many schools also choose to deliver their presentations to a primary school feeder class, which again just increases the engagement of this program. So the long-term aspect of this project is something that really helps it to stand out and gives our team of mentors a much longer-term relationship that's built up with this group. So this is our last slide, and this is just more pictures of our team from various different events that we've had over the years. We'd just like to say a huge thank you to all of our many volunteers and PhD mentors, because without them, Really Small Science and Young Chemical Ambassador would not be the team that it is, and it's really thanks to their great work that we've been able to be nominated for this award. So thank you.
Okay, thank you very much. So for the final time today then, if there are any questions, please type them into the questions box now. We do have a couple already, so let's get started. First one's actually from Francois, one of our earlier presenters. He says, we do have a similar initiative from Dow Silicons in Belgium to teach our local schools and junior generation that chemistry and sciences are essential. Could you see things from your work that might be shareable and exportable for possible reuse in Belgium?
So I mean, it sounds like a great opportunity to internationalize even further Really Small Science. So absolutely. I mean, what I would say, I don't know quite how we share contact details, but you can find us quite easily if you search Really Small Science. And we'd definitely be happy to talk about how we can work together, because that would be a really great idea.
Great, and we can put you in touch as well, obviously, outside of the webinar. A couple of questions very similar. Have you seen, or is there a plan to track the results to see if your work leads to an uptick or in undergraduates signing up for ChemEng or other engineering science courses?
So I guess sort of, let's say anecdotally, or not necessarily entirely statistically completely reliable, but we have certainly seen an increase in our recruitment from these so-called areas of multiple deprivation that is the way kind of different postcodes are classified in Scotland, if you like. So now obviously we can't immediately prove a causal link, but I think we're quite confident that we are having an impact in that way. And in a way as well, my feeling is, I mean, when you do one of these events and you see the expressions on the kids' faces and so on, you know you're having an impact. Now, whether that turns into a very long-term science career and a Nobel Prize or two, or whether it's just a kid goes away feeling a bit more excited about life, I still think it's a really valuable impact. So it's definitely there. One thing we are trying to do, one of the things I'm planning at the moment, is actually to try and study this more carefully. So hopefully we'll be running a project next year where I'm going to try and get some of our undergraduates to actually start investigating, maybe going back to some of the people we've worked with before to talk to them more about what has been the impact over the years.
Okay, thank you very much. That wraps up the questions, so thank you very much. And that actually wraps up our presentations as well. You may recall we had problems earlier on with a presentation by Imperial College London and Sipsmith. Unfortunately, we haven't been able to rectify the problem with a corrupt video. Instead, you'll see a link to their presentation appear in the questions box in a moment. So if it's something you are interested in, by all means, copy the link and go and watch that perhaps after the webinar. Unfortunately, it's not something we're going to be able to bring you within this session. So let's move on. And before we do that, let me thank all of our finalists for being with us today. I'm sure you'll agree, a range of very different, very interesting presentations. But we've reached the stage that you've been waiting for, and that's to find out our winner. So let me start with our highly commended entries, and they are the joint entry from the University of Leeds, Imperial College London, NNL, the Nuclear Decommissioning Authority, Sellafield Limited, and the Universities of Lancaster, Loughborough, Birmingham, Bristol, Manchester, Sheffield, Strathclyde, Surrey, and UCL. I hope I got them all. And the joint entry from Imperial College London and Sipsmith. So well done to everybody associated with those entries. But now I'd like to hand back to John Lawton from Baker Hicks, who's going to reveal the winner.
Hi everybody, and thanks very much indeed, Matt. And yeah, congratulations to everybody, some great submissions. But ladies and gentlemen, the winner of the IChemE 2020 Team Award, sponsored by Baker Hicks, is the Centre for Process Innovation. So congratulations to everybody involved in that team.
Thank you, John. And yes, congratulations to the CPI. And John Williams, if we can get you back on the line, how does it feel to be an IChemE Award winner?
That's really great. Thank you for everyone. Thanks for the judges and everything. It's really good. The my team is going wild from all of our teams saying how great it is. Yeah, I guess if I can say anything, I'd say thanks to Joe, our manager, for being so supportive and kind of helping us all the way through everything and letting us do things like make a video. And thanks for the team for being so easy to work with and so fun. It makes it a pleasure to work at CPI. So thanks everyone.
Great. And tell us, whose idea was the video?
It was mine.
Well done, very good. And I suppose one thing we should point out is that our judges obviously judge the entry based on the entry form as opposed to the video. So do you want to just tell us a little bit more about the work of the CPI, because some of the people on the call won't necessarily know much beyond the video?
Yeah, so CPI, it's based in the northeast of England, and essentially it was originally, it's partly government funded, partly commercial, and it was set up to kind of help the UK industry. So it works in the process industries, and the idea is to support SMEs and large companies developing new technologies. And it's about 400 or 500 people large, and we're one of the teams within CPI, and we do process technology development. So we take things from lab scale up to large scale processes. So we're kind of the process engineering part of CPI.
Okay, well look, thank you very much and well done to the CPI, and a big thank you to everyone who's joined us today, and of course our sponsor Baker Hicks. Don't forget, tomorrow we announce the winner of our top prize, the Outstanding Achievement in Chemical and Process Engineering Award. That's tomorrow afternoon, so hopefully you can join us for that webinar. Once again, it's free to attend and open to all. But for now, it's goodbye and congratulations to the Centre for Process Innovation, winner of the IChemE 2020 Team Award.